So we begin by discussing sets. So here, a set can be considered as a collection of well-defined objects. Now here, these objects are going to be the members of the given set. To begin with, we're going to list few examples. So let's go through few examples to understand what a set is. So here we have 10 examples of set. Go through each of these examples. If we observe here, the odd numbered examples 1, 3, 5, 7 and 9. These 5 odd numbered examples are defined, and defined in the sense that here the members of the set are listed here. For instance, if we look at the first example, the numbers 1, 2, 3 and 5. That means here we are considering a set which contains the objects 1, 2, 3 and 5. So here we have listed the 4 objects of the set or the members of the set. Similarly, if we check number 3, example number 3, we have the vowels of the English alphabet. So here we have listed all the 5 vowels. Then coming to number 5, here we have listed 3 students, and the name of the 3 students are given here, Joe, John and Jane. So the members are given to us. Similarly for number 7 and number 9. So here we have defined the set by listing out its members. Now coming to the even numbered example. If we look at the first example, the solutions of the equation x squared minus 4x plus 4 equals to 0. So here we have not actually listed out the members of the particular set, but what we have done here is given a property of the set. So that means if we solve this equation or this quadratic equation x squared minus 4x plus 4 equals to 0, its solutions are going to be the members of the set. So it's not directly stated here, but we have given in terms of a property. Similarly, if we check example number 4, the people living in Antarctica. So here, instead of listing out all the number of people living in Antarctica or listing out the names of each of the person living in Antarctica, so here we are only mentioning all the people. Coming to number 6, the students who are not present at school. So this is also going to be a number. It's going to be defined, but here we are not exactly listing out the students who are not present, but instead we are specifying that the list of all the students that were not present at school. Similarly goes for example number 8 and example number 10. Now let's talk about notation, how to denote a given set. So usually what we do, we'll consider all the letters of the English alphabet in uppercase, or let's say A, B, C, and the rest of the alphabet. We can pick any one of the alphabet in uppercase, and that's going to denote the set. So the A, B, and C, these are the set that will define. These are the alphabets that's going to define the set. And if we have the lowercase letters, let's say A, B, and C, then these letters are going to represent the members of that given set. For example, let's say we consider example number 3, the vowels of the English alphabet. So we're going to denote the set by the letter A in uppercase, and then we're going to list out all the elements or the members of the set. Now how do we represent it? We are going to use a symbol. We're going to use the parentheses, and within the parentheses we're going to list all the letters of the English vowel. So we have A, E, I, O and U. So this is how we can represent a set, which is the members which is included within the parentheses that has been represented by the letter A in uppercase. Now this is a way of representing a set. This is referred to as the tabular set. They are the tabular form of a set. Tabular form, that means we have listed out all the elements of the given set, and then we have enclosed them within these two braces. So this is one of the way of representing a set. There is one more way. So let's talk about the other way. So actually the example, the way I picked the example is very important here. The odd numbered examples, these examples can be expressed in the tabular form. So let's try to do one thing. Before moving on to the next form of writing a set, we're going to use the odd numbered problem to represent and represent them in terms of the tabular form. So we've already worked with 3. Let's work with number 1. So here in number 1, let's say we represent it by the letter B. So B is going to be the set. This will be equals to, we're going to use the braces, and inside the braces we're going to list the numbers in any order we like. So we can write 1 2 5 comma 3. So here the order does not matter as long as we list all the elements within the bracer. So here we are representing the set B as the set containing the elements 1 2 5 and 3. Moving on to the fifth example. So here we have 3 students, Joe, John and Jane. Let's represent the set by the letter C. So we have, this will be equals to the braces, and within the braces we're going to list the name Joe, John and Jane. Or these members or the elements of the set are going to be separated by commas. Coming to the seventh one, we have 3 countries, Japan, South Africa and Canada. So let's say we represented the set by the letter D. So we will list the name. So I'm representing it by J for Japan, SA, that will be South Africa, and Canada with C. So here, don't get confused that I am listing the name in uppercase. So okay, let's try to avoid this confusion. It's better to write down the full name. So here we have Japan, we have South Africa, and we have Canada. Okay, so let's not write in this particular fashion because you might get confused that we are considering the uppercase letter inside a set, although we can represent it. We'll come to that much later. Okay, now let's go to the ninth one. The ninth one is the set of odd integers 1 3 5, and it goes on. Well, we can denote it by the letter E in uppercase. This will be equals to the curly braces, opening curly braces. Then we'll list the elements 1 3 5, and this continues, and we close with the curly brace. So this is how we can represent the odd numbered examples here. We are representing the sets in the tabular form by listing out all the elements. Now, how do we represent the even numbered examples? Because these are also sets, and we will not be able to express this in the tabular form, although we can. I mean, there's a much better way to represent these sets, and let's go to the other form. So let's pick up one example from the even number. So let's start with number 2. So this is the solutions of the equation x squared minus 4x plus 4 equals to 0, and we're going to represent this by a different way. Let's say we name this set as set A. Now set A, we're going to rewrite it, so it's very important. So we're going to use curly braces. Now inside this set, we're going to write the element x. So we're saying that A is a set which contains the elements referred to as x. So here x is unknown. We're going to choose x in such a way, such that this vertical line is going to tell us that it's referred to as such that x is a solution of the quadratic equation given by x squared minus 4x plus 4 equals to 0. So here what we have done, we have listed the property of the given set, and this way of representing a set is referred to as the set builder form. Now we can be always creative while writing a set builder form. We can also express it as, let's say we have the set A. So here we will consider the element. We can consider the element not necessarily x. We can consider to be A as well, but it has to be in lowercase. So we're considering A as an element of the set A such that A is a root. So A is going to be a root of the given quadratic equation, given by x squared, so minus 4x plus 4 equals to 0. Of course, we can also write it in the previous form, that is the tabular form. All we have to do is solve the given quadratic equation. So x squared minus 4x plus 4 equals to 0. The roots of the given quadratic equation, that's going to be x equals to 2. Now that means we can also represent set A as the set containing the element 2. So of course, the quadratic equation is going to have repeated roots 2, 2. But while writing in the tabular form, we only can pick up one of the 2 roots. I mean, if they're repeated, then we only pick one of them. So some textbooks prefer to use a colon here. So this translates to such that. And some textbooks will write it in terms of a vertical line. So this also refers to as such that. So it's very important to understand how we read a particular set. So let's work on the next example, the people living in Antarctica. So how do we express this particular set? So we go to number 4. Let's consider it to be the set B. So here we have B is a set which contains the elements X. So what is X here? So we're going to specify X. So X such that X represents, let's say X represents the people living in Antarctica. Now let's present the example number 6. So here 6, we're going to consider it as set C. So C is talking about the set of all the students who are not present at school. So we can represent as C is a set which contains the elements X. Let's assume that X represents the students. So C is the set which contains all the students which we are denoting by X such that X is not present. X is not present at school. Then coming to number 8. The 8 we can represent it as let's call it the set D, the capital cities of Asia. So here we can say D is the set containing all the cities. We're going to denote the cities by the letter A, or let's say let's denote it by the letter B, such that B presents all the capital cities of Asia. And finally number 10, 10 let's say we denote it by the letter E. The E is the set containing the rivers in North America, which are going to denote it by the letter X, such that X represents the rivers in North America. So these are the two different ways of representing a set. We can either use the set builder form or we can use the tabular form. Either way, both of them are correct. Sometimes it becomes easier to express a given set in the tabular form, like in the previous examples that we have done, in the odd numbered examples, or listing out all the vowels of the English alphabet. And sometimes it becomes easier to express a set in the set builder form. So we are going to use accordingly. We'll do more examples and this will help you make the choice. This will help you make the right choice in which particular method to use while expressing a given set. Okay, now that we have understood how to represent a set, now let's come back to the members or the elements of a set. So let's say we start by considering an example. So let's say we have a set A which contains the numbers 2, 4, 6, 8, and it continues. Right. Now clearly this is the tabular form. We're representing the set A in the tabular form. Before talking about the element, let's also try to represent the given set in the set builder form. So we can also represent it as, so A is a set which contains all the values X. Now what is X? Now X could be 2, it could be 4, it could be 6, or it could be 8. So here instead of listing out all the elements, we are writing it in a compact form as X, such that X clearly is an even number. So here X is an even integer. Let's call it an even integer. And because we know that integer could be either positive or negative, so here we are also specifying that X is greater than 0. We have to understand how this set is written and how it can be read. So this also translates to A is a set containing X. So here the colons will translate into such that X is an even integer. X is an even integer. And we are going to express the comma as and X is greater than 0. Or we can say that X, or instead we can write that X is positive, as we can observe. So instead of expressing the given problem in a statement form, it's much easier to express it in a compact form, either in the tabular format or in the set builder format. Now let's say we pick up an element from the set. So here let's say we pick up the element 2. Now clearly 2 belongs to the set A. That's evident from the example here. 2 belongs to the set A. So there is a compact way of writing this. So here we will be writing the element first. 2 belongs to the set A. So here, this is how we can represent the statement 2 belongs to the set A in a more compact form. Now, if we pick up, let's say, the number 3. Now, 3 does not belong. So, 3 does not belong to the set A. Now, how do you represent it? All we have to do is write 3. So, we're going to use the symbol which looks like an epsilon, and we're going to cut the symbol which represents it does not belong to the set A. And you can see that this is much faster and a compact way of writing the same statement in a mathematical form. So whenever we have the symbol epsilon, so that it means that it represents belongs to in set theory. And if we have the other symbol epsilon and we cut that symbol, then this will be representing does not belongs. It does not belong to the given set. Now, I would like to make a point here that A, if we write in this fashion that A belongs to 2, this is an incorrect way of writing. That's because this tells us that set A, if we convert it to a statement form, how will it read like? It will read as set A, the set A belongs to the element 2. That does not make any sense because 2 is contained in A. It's not the set A that is contained in 2. So that's why it's very important how we write it, the notation wise. So we start with the element. So this is going to be the element. We start with the element. Then we use the symbol either belongs to or does not belongs to, followed by the set. So you have to be very careful when you write or express belongs to when you express an element in this particular fashion. Now clearly from this example we can also combine one or more element. For instance, here we can say the 2 comma 4 belongs to the set A. So we are writing it in the compact form. It actually means the 2 belongs to set A and 4 belongs to set A, but instead of writing in a compound form, we can also write it in a compact form as 2 comma 4 belongs to set A, and we can also include more than 2 elements. Now, very often in most of the examples that we will be dealing with later on, we will be encountering certain symbols. For instance, the letter N in uppercase, but we're going to cut one of the lines, one of the slanted lines. Then we will be seeing the letter Z. So this can be also, we'll have a double slanted line here. Then we have R, and then we have one more vertical line. So there are different types of letters. These strange letters, these will be this we will be seeing often again. So we have the letter Q, then we will have the letter C. What does it mean? So here it's very easy to remember. N represents the set of all natural numbers. So when we have the set of all natural numbers, so in a very compact form, we can represent it by using this letter N, set of all natural numbers. And if we want to express it in the tabular form, it will be simply 1, 2, 3, dot, 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 enclosed within the parentheses. Then the Z. The Z represents the set of all integers. The set of all integers. The set of all integers will be what? All the negative numbers, or let's say -2, -1, 0. Then we have 1, 2, and it continues and enclosed within the braces. R is going to be the set of all real numbers. The set of all real numbers, so it will be including all the rational, irrational, as well as the natural and all the integers. So here I'm not stating the tabular form. Then Q. Q is going to be the set of all rational numbers. The rational numbers. Now let's try to represent the set of all rational numbers in the set builder form. So we're going to consider as a set containing some elements. All these elements are going to be of the form P over Q, such that P and Q belongs to the set of, let's call it, integers, with a condition that the denominator, that is Q, this cannot be equals to 0. So that means P and Q are all integer values and Q not equals to 0. And if we divide P with Q, then what we get is a rational number. And also we have to specify that P and Q must not have any common factors. So let's also specify, and so you'll have to use a comma here. That means and P and Q does not have any common factors. So that's the definition of a rational number. So this is the set of all rational numbers denoted by the letter Q in uppercase with a slanted line. Then C. So C, of course, we are not going to encounter this. This will come much later. This is going to be the set of all complex numbers. So if you are familiar with the concept of complex numbers, and then this will be encountered there. Sometimes we have some other forms for the set of integers. So if we want only the positive set of integers, then we denote it as z plus, and if we want only the negative set of integers, then we denote it as z minus. Similarly for Q also, we can have the positive rational numbers or negative rational numbers. So this will be dealt with accordingly. So this is the end of the session for today, and we have discussed what a set is, and we have talked about different ways to represent a set. So we have talked about two ways. One is the tabular form, where we list out all the elements that belongs to a particular set, and the other one is the set builder form. So set builder form is a way in which we represent the properties of the particular set, and both of the two ways are used accordingly, and these are compact way of expressing a set. Then we also introduce the symbol belongs to or does not belongs to. So in the next lecture or in the next session, we'll be working on few numerical problems that is going to help us solidify our ideas on whatever we have learned in today's session.